Hey everyone, welcome back to my channel, where we dive into solving LeetCode problems and explore the world of coding. Today, we're going to tackle a medium-level problem that's all about finding the maximum number of elements in a subset. So, let's get started and see how we can solve this problem efficiently. The problem statement asks us to find the maximum number of elements in a subset where each number is half of the previous one. We're given an array of integers, and we need to find the longest sequence of numbers that satisfy this condition. It might seem a bit tricky at first, but don't worry, we'll break it down step by step. To solve this problem, we need to find the longest sequence of numbers where each number is half of the previous one. Think of it like a game of divide and conquer. Imagine you're playing with a bunch of blocks, and each block can be divided into smaller blocks. The goal is to find the longest chain of blocks where each block is half the size of the previous one. The key insight here is to use an unordered map to store the frequency of each number in the array. This allows us to efficiently check if a number is present in the array, which is crucial in finding the longest sequence. Now that we have the intuition, let's walk through the solution. We start by creating an unordered map to store the frequency of each number in the array. Then, we iterate over each number in the array. For each number, we check if its frequency is greater than 0. If it is, we start dividing the number by 2 and check if its half is present in the array. If it is, we increment the length of the current subset. We keep doing this until we can no longer divide the number by 2. If the final number is 1, we update the length of the subset to twice the length minus 1. Otherwise, we just use the current length. Let's take a look at the C++ code. We start with a class solution that has a method called maxLength. This method takes a vector of integers as input and returns the maximum length of the subset. We create an unordered map called frequency to store the frequency of each number in the array. Then, we initialize a variable called maxLength to store the maximum length of the subset. We iterate over each number in the array using a for loop. For each number, we increment its frequency in the map. Then, we start a while loop that checks if the number can be divided by 2. If it can, we divide the number by 2 and check if its half is present in the map. If it is, we increment the length of the current subset. We keep doing this until we can no longer divide the number by 2. If the final number is 1, we update the length of the subset to twice the length minus 1. Otherwise, we just use the current length. Finally, we update the max length if the current subset length is greater than the max length. Now, let's talk about the time and space complexity of the solution. The time complexity is O(n log m), where n is the length of the input array and m is the maximum value in the array. This is because we are iterating over each number in the array and performing a while loop that runs in O log m time. The space complexity is O(n), where n is the length of the input array. This is because we are storing the frequency of each number in the frequency map. And that's it, everyone. We've solved the problem of finding the maximum number of elements in a subset. I hope you enjoyed this explanation and learned something new. If you have any questions or want to share your approach, please comment below. Don't forget to like the video, subscribe, and comment your approach below.